Hey guys, this part of my live stream breaks down network topologies with an analogy that makes it simple to understand, so I'm gonna let you enjoy the video. So guys, again, I'm just repeating what is a network topology. You will see this concept a lot, and network topology is, again, it describes how devices are arranged, where they are located, how they are connected to the network. So this include two things, okay? This include, let's use my pen here. The first thing, oh my god, by default is go back to the big one. So network topology could be defined like this. The first one is the physical topology. Okay, the physical topology, which means how devices are physically linked with each, like between each other, how they are linked, how the cable, sorry, is it cables, is it wireless, what are we doing? And it's actually better if I, yeah, so yeah, I think it's fine. And then the second one is the logical topology. Okay, logical topology. What is the logical topology? It means how data flows between devices regardless of physical layouts. If you want to have, I will give you guys the best analogy for this. You need to think of a physical topology as a city map showing roads and like buildings and all those type of things, like the structure, while logical topology is the traffic flow on those roads. So it's the vehicle that, so the vehicle is like the packets that go from there to there. So the vehicle that go, for example, in my case, I don't know, like from Paris to Lille to Lyon, etc., etc. So let's go back here, and I'm gonna give you the best, for me it's the best analogy, to be honest. So look, road map. Maybe we should make city, it will be better. City map. Yes, perfect. So look guys, here you have what you see here. It's it's a perfect picture. What you see here, it's the actual physical topology. I'm gonna mark it here. No, you can't. Let's put it there and there. So here you have, oh sorry, here you have the physical topology. Here, the house, the road, okay, the road, which is in reality the cable. Like, it's a device. For example, this one is a laptop, this one is a server here, another server, a laptop, another laptop, a phone. Like, all of these things are part of the network, okay? And then what you have here, the road, is the actual cable, okay? So the cable, I can represent it this way. So this server is linked with this laptop. This server is linked to this phone, and this one to this laptop, this one to this, etc. And this server is same, is linked to this laptop, to this other server, for example. So, and how they travel? They travel through logical topology. It means that this actual core here, which is the data, he will go from the server and, for example, do this. Stuck, and then go here. Okay? And now it's the work of the network engineer to make the best path possible. Maybe after maybe 1 year of him like changing the network and doing things better, now maybe the data could go directly from here to here. But in reality, guys, what is happening? If you take, for example, your home network, what is happening in reality? Let's say you have here your, very simple, you are with your family and you have a house. Okay, you have a house and you have here sorry, you have yes, it's a house, but it's, for example, your laptop. Okay, it's your laptop. Let's say Johan. Okay, Johan's laptop. Then you have here another laptop, which is Luca. Then here Sofian. Okay, I'm just putting a random name, and I'm not pointing anyone here. And then you have here, let's say D for David. And what you have in the middle, let's say all of this section here, it's the router. Here it's the router. Well, sorry, router. So what is your city? How your city function? How the core, which is the data, work? It's actually very simple. It works that way. This one connected to here, this one connected to here, this laptop connected to here, and this other laptop. I didn't make any phone. Let's say here it's the phone of Tristan. Okay, and Tristan's phone linked to the router here, to the router, and then the router communicate through internet. Okay, like they say, the cloud internet, which is in reality, guys, I covered this many times, it's only router and physical server. There's no cloud for, it's a very big misconception to have them calling them cloud. To call the internet cloud, it's a big mistake according to me. So you have here internet, which again is just router. Just many router, many servers. So how look, this is actually, guys, we are actually pointing network topology. So it means that whenever, for example, Sofian want to connect to a website like Canva, for example, myself here, so canva.com, he will go to the router and, sorry, blue. He will go to the router, so he will take a core here, he will use this core, go to the router, and the core going to leave the hometown through router, because router, they know about IP address, and connect to Canva. Okay, and then it will go back, connect again to router, and go back to Sofian's laptop. Okay, it's a very important notion and concept to know this, because guys, if you want to troubleshoot anything, you need to know what is the network topology of your system. For example, you have a printer here. Many people have confusing about this. You have a printer here that is connected to the laptop of Luca. What is the network topology for this? First, here is Luca laptop. First, it connects to the printer and then to the router. Is it true what I'm saying? Or is Luca communicate to the router and the router communicate to the printer? And yes, guys, there is no connection between them. There is connection between him, Luca, the router, the printer, the router, the device. And many people, and if you want to troubleshoot anything, you need to be aware of this, okay? And there is a command line. I think I forget about. I have how you say it in English? I forget the name when you lost memory of something. Yeah, I actually forget, but you could have routing command line for what I'm trying to routing path data command line, and here you will see the command prompt for, yes, it's trace route. You can use trace route to say, for example, okay, let me know if I am for example here, sorry, for example here it's your printer, and you want to see like how the network is actually working, and how it is, what is the network topology, simply as this, and you will do trace route to your laptop. And figure it out, how your packets travel. Okay, you will see how your packets travel. So he will tell you first go to the router and then you go to the printer. Okay, so it works that way. So I think we did. So let me talk to you. Yeah, the next thing that I want to show you, it's just the different types of network topology. You have different types of network topology. The one that I just showed you guys, if I'm not mistaken, it's the store topology. Because for the home network, even company's network is also store topology, but it's a mix between store topology and bus topology, which is like bus topology is cable. Like you will see cable going from everywhere. Like everyone on your network, you will see cable a little bit like this, like my representation. So the laptop will be connected to the router through only cables, but usually these days it's only about store topology. It means that all devices are connected to a central hub. By the way, store topology and bus topology, it's almost the exact same. It's all devices are connected to a central hub or switch, but bus topology, if I'm not mistaken, is only through cables. Okay, but store topology is wireless. Okay, it's more wireless. Now the problem with in a big company, store topology is not a good thing, because it's a single cable for bus, or in the store a symbol. If the central device, let's do this way, if the central device, hub or switch fails, the whole network is affected, and it's very bad. It's very bad for the company's network. So then you have ring topology, but we don't need to cover this. But the one that is important and is present in sorry in companies is mesh topology. And mesh topology, the physical layout is that each device is connected to every other device. And the example that I could give you for this is um, high redundancy corporate network. I can show you right now. Let me just wipe this. So I'm gonna show you what it's about. Okay, I know some people will be angry after me if I don't let the small details. Okay, so for example, mesh, a perfect example of mesh topology. I don't know if I put mesh if they will give me. I'm not sure. No, they won't. They won't give me. Yeah, let's use this one. For example, you have 3 servers, okay? And what you need is that in order to have a mesh topology, both need to be connected through a cable, but not like this. You will have like this. You will have this one that is connected, like let's say first, second, and third, and the first is connected to the third. The second is connected to both of them, and but it's like more than this. It's something like this. It's maybe we could look on the internet and you will have a proper way of looking at this. But it's like high redundancy in a way that all the servers are connecting between each other. And of course, guys, it costs a lot of money. It costs a lot of money for companies. Sorry. mm, okay, you see. Yeah, because I forget very important things. But this one looks like a ring. It doesn't look like mesh. But you just need to know that, okay, full mesh topology. You see? So this one, sorry, I was pointing my hand. I'm really tired. I was pointing my hand. Um, this laptop is connected to every other laptop, and disconnected, and same for this one. This laptop is connected with all other laptop. So it's what we called mesh topologies. Okay, guys, that's good. We need to go a little bit faster than this. So, guys, it's fine. Like really, we cover a lot. We really cover a lot for this topic. Then what can I say more than this? Let me check if we cover everything, because I didn't want to left to um yes, perfect, perfect. We will cover this. It will be the last. Normally it wouldn't be that long. Okay, guys. So the last thing that we'll cover is the OC model. You see how much we have talking about networking, and it's not we are not done yet. I know that OC model, it's really a problem for a